Hey guys, my name is Trevor Sullivan. I am a solutions architect with StratusGrid, and I'm also an AWS ambassador. And welcome back to the StratusGrid video channel. Before we get into today's topic, I wanted to give you a brief introduction to StratusGrid. So StratusGrid is an AWS Premier Consulting partner, and we're also an independent software vendor, or ISV. We have a SaaS platform called Stratosphere, which you can find at our website, stratusgrid.com or stratosphere.app is where our SaaS platform resides. And essentially, what Stratosphere allows you to do is to get visibility across all of your cloud environments in AWS and Microsoft Azure. And you can get a centralized view of any cost savings opportunities. You can get insight into your spend, a breakdown by service or by account or subscription, depending on which cloud platform you're using. And it gives you visibility into opportunities to implement cost savings as well. So just to give you a couple of brief views of our platform here, this is our findings view where you can provide a bunch of different filters to zero in on which cost savings opportunities you want to implement. There's lots of different filters available here to help you narrow down which accounts you're looking at, which services you're looking at, and which specific types of findings that you're looking for, as well as the level of effort to determine, what are my low-hanging fruit and what are some of the higher effort items. Also, in the analysis view over here, this is what allows you to filter your spend by your services or by the cloud service provider like AWS or Azure. You can also group by account or by service or cloud service provider here so you can get different perspectives into your cloud spend. And one of the great things is that you can actually expand out your discounts as a raw dollar amount or a percentage of your total spend on a per service or per account or per cloud provider grouping, depending on what you've selected up here for group by. And you can also see what your potential savings is broken out by a level of effort here. So as you can see, we are tracking our low effort and medium effort savings potential here over a period of time. So there's a lot of useful data, a lot of useful analytics that you can use in this platform to help you implement cost savings. And in the findings view, if you take action on an individual item here, you can actually change the status of it and say that this has been resolved. Or if this is a known financial risk, you can say that this is an accepted risk, and then you can set a reminder. Maybe if you want to be reminded a year out, you can set an acceptance end date to get reminded about that in the future and provide a comment. And then you can see any historical commentary that's been provided on this particular resource so that your team can collaborate on your cost optimization projects. So if you're interested in seeing a demo of Stratosphere or running a POC of Stratosphere, feel free to reach out to us at stratusgrid.com, and we would love to book a demo meeting with you. All right, so the topic for this video is going to be on the Microsoft Azure Blob Storage service. This will be an introductory video, kind of a high-level overview of the Azure Blob Storage service. And I did want to mention that there is actually 4 different types of storage available in the Azure Storage Account service. So there is blob storage, there is file storage that allows you to create SMB and NFS file systems. There's also queue storage that allows you to have a queue where your applications can put data into the queue and then take messages off the queue. And then there's also what's called table storage, which is a NoSQL database that allows you to store data in a non-relational manner using a partition key and a sort key, very similar to Amazon DynamoDB, if you're familiar with that service, or something like MongoDB. There's a lot of different NoSQL databases out there that have a pretty similar architecture to Azure table storage. But for this particular video, we're just going to hone in on the Azure Blob Storage service in particular. Now, Azure Blob Storage is very similar to Amazon S3 Object Storage or Simple Storage Service. If you're already familiar with S3 or other object storage services that are compatible with S3, like Backblaze, B2 Storage, there's Wasabi Storage, DigitalOcean, and Akamai, I believe, also provides S3 compatible storage. Now, Azure Blob Storage is a separate API that is not compatible with Amazon S3 APIs. So any existing tooling that you're familiar with that utilizes S3 APIs is not going to work with Azure Blob Storage. However, there are plenty of SDKs and tools that allow you to work with Azure Blob Storage that are cross-platform as well. So there's really no need to use any S3 tooling because there is adequate tooling to work with Azure Blob Storage. Now, in Azure Blob Storage, there's actually several different types of blobs available. So we talked about storage accounts provide 4 different types of storage services: the file, blob, queue, and table. But then there, within the blob storage service in particular, there are 3 different types of blobs. There's what's called block blobs, and the block blobs are generally going to be what you're talking about when you refer to Azure Blob Storage. That's probably going to be the most common type of blob that you are dealing with. But there are also 2 different types of other blobs called append blobs, which are designed specifically for appending data. So that might be useful for things like logging, where you are always appending data to log files. You're not really going back earlier into the logs and deleting random entries out of there. You're just always appending data to log files, for example. And then there's also another type of blob called page blobs. So there is a document over here in the Microsoft Azure documentation called Understanding Block Blobs, Append Blobs, and Page Blobs. And this article goes into depth about when the different types of blob storage are being used. So for example, down here with page blobs, you'll see that page blobs are generally used for the Microsoft Azure disk service that support virtual machines, right? So if you create an operating system disk or a data disk, that is generally going to use your page blob service rather than append blobs, which doesn't really make sense for a general file system. And it also does not use block blobs. So this is where you can learn more about the different types of blobs here. But again, generally speaking, the most common type of blob that you're going to come across in the Azure Storage Service is going to be the block blob, because that provides the maximum flexibility for general file storage, right? So it doesn't have the limitations of append blobs, and it also does not have the limitations of page blobs, as mentioned down here. Again, page blobs are generally used for Azure Virtual Machine disks. So for your general purpose storage, that is where block blobs come into play. So that's the one that we're going to focus on predominantly for this video here. Now, in the Azure Storage service here, you have to create what's called a storage account. So in other services like Amazon S3, if you're coming from an AWS background, in an AWS S3, you actually just create what's called a bucket, and then you can immediately create objects inside of that bucket. You can upload files into the bucket or just create data directly using the S3 APIs inside of a bucket. But in the Azure Blob Storage service, there's a little bit of an extra layer. So there's something called a storage account that you create, and there's a couple of different pricing tiers available for the storage account that you create. So you can create a standard storage account, and that provides access to your 4 different types of storage: the queue, table, blob, and file storage. But then there's also a premium storage here that provides access to block and append blobs with low and consistent latency. Now, when you create a storage account, you want to think about the purpose of the data that you're going to be storing inside of that storage account. So if you have an application that has a really high transaction rate, then premium storage might actually make sense for that application. And you are going to pay a significantly higher cost for premium storage. So as you can see in this table down here, if you create a premium storage account, you are paying 15 cents per gigabyte of storage. And that's compared to, for your standard hot storage on a standard storage account, it's only at 1.8 cents per gigabyte. So you're looking at roughly 9x, almost 10x of the price of standard storage to use premium storage. So again, generally speaking, your default is going to be to create a standard storage account. But if you do have an application that specifically needs high throughput for the blob service, then you can go up to the premium storage tier. But just be aware of the increased cost for the premium storage account. Now, there's also a cost for the operations, or what are called requests, that you make to the storage service. So again, with the hot tier here, you're paying 6.5 cents per 10,000 write operations, and you are paying half of a penny per 10,000 read operations. And with premium storage, you can see that the cost for write requests is actually lower here, and the cost for read requests is actually a little bit lower as well. So even though the storage cost is higher for premium, the request cost is actually a little bit lower per 10,000 requests here. Now, on standard storage, you can also have what's called cool or cold or archive storage tiers. And there's a, I believe, 30-day, 90-day, and 180-day, respectively, minimum for each of these storage tiers. So if you move a blob from hot to cool storage, I think it's a 30-day minimum. So even if you decide to delete a blob after 5 days from the cool storage tier, you're still going to get charged that minimum. And then the same applies for cold, but instead of 30 days, it's a minimum of 90 days. And again, I think that is mentioned somewhere down here in the small print. And then for archive, it's a minimum of 180 days. So again, if you move a blob from hot to archive storage and you delete that blob after 5 days, you're still going to be charged for the minimum of 180 days of archive tier storage. So just be aware of those minimums as you are strategizing how you're going to use these different storage tiers. Now, there is a lower cost for the actual raw storage. So on hot storage, it's 1.8 cents per gigabyte. For cool storage, it goes down almost by 50%, down to 1 cent per gigabyte. With cold storage, it goes down about another 60%, down to 3.6 cents per gigabyte. And then archive storage goes down significantly further, down to 2/10 of a penny per gigabyte. So again, with archive storage, you are going to save a lot on the raw storage costs. However, the important thing to note here is that as you go down the scale from hot to cool to cold down to archive, the cost to actually perform various operations and retrieve data from those different tiers also goes up. So not only is there a minimum of the storage time, 30, 90, or 180 days, however, there's also an increase in the retrieval costs. And that you can actually see right down here. So for operations and data transfer, you can see that the data retrieval for hot storage, there's no additional cost. However, if you've moved data into cool or cold or archive tier storage, then you actually do pay a retrieval fee. Now, one of the other high costs here is the actual operations that you're performing. So read and write operations, you can see for hot storage, it's for read operations here, it's 0.5 cent per 10,000 requests. And then for cool storage, that goes up more than double, almost triple the cost to 1.3 cents per 10,000 operations. And then again, cold storage goes up 10x from that. And that is going to go from 1.3 cents per 10,000 operations for read operations up to 13 cents per 10,000 read operations. And these numbers might not sound very large to you, but if you're storing a very large number of objects in Azure Blob Storage, then the cost to retrieve that data is going to go up pretty significantly as you go further down the storage tiers here. So you really want to think about, am I going to need to access this data within a particular period? And if you are, then it may make sense to keep that storage in the hot storage tier. But if you are creating a backup that's only going to be required for an absolute worst case scenario, like a total business outage, then it might make sense to stick that into cold storage or potentially even the archive storage tier. It really just kind of depends on what your risk tolerance is. But check this out. For archive storage, it goes from 13 cents all the way up to $6.50. That is a huge increase for your read operations here. So that's where a big increase in your costs is going to come from the archive storage here. It is actually a little bit cheaper from cold to archive storage for your write operations. But again, the retrieval cost to the read operations here is where a bulk of that cost is going to come from, along with the retrieval cost. And there is, on archive storage, there is an optional high priority retrieval that's not available in the other cool and cold tiers. And if you choose to go with that route, that is going to increase by 5x your per gigabyte cost to retrieve data. So if you have something in archive storage that you need to immediately get out of archive storage due to, again, something like a business total outage, then your archive high priority retrieval cost is going to cost you a fair amount, especially for large amounts of data. If you have a 5 terabyte database, then it's 5 terabytes divided by gigabyte times 10 cents per gigabyte. And so, I can't do that math in my head right off the bat, but it's going to be a pretty significant cost to retrieve a large amount of data. So just keep those things in mind as you are strategizing how you want to use this storage service. All right, so as we talked about, there are a couple of different types of storage accounts. There is an article here in the Azure storage documentation that talks about when to use a standard general purpose storage account and when you might want to use a premium storage account for block blobs, for Azure file shares, and for page blobs for Azure virtual machines. So feel free to check out this article. It talks about when to use different types of storage accounts. But again, your default is generally going to be just to choose the standard general purpose storage account type. This gives you the most flexibility because it works with all 4 types of storage: blob, queue, table, and file storage. And it gives you the ability to do redundancy. It gives you, so you have replication either at the local level within a region, or you can actually do what's called GRS, geo-redundant storage, where you can replicate your data to another Azure region as well for higher durability of your data. So if an entire region in Azure were to disappear, you would still have another copy of your data replicated out to another Azure region. Okay, so the articles here on storage account overview talks about the different types of storage accounts. And then this article talks about the different types of specifically blob storage. And then what we're going to do now is actually talk about how to practically utilize this service. And then we'll go in and talk about some of the metrics that are available for Azure storage as well, at least for blob storage. So if you go out to the Microsoft Azure portal, typically the first thing that I do is create a new resource group here. So we'll just create an empty resource group, and a resource group is just kind of a logical container to hold different types of resources. So I'll just call this Trevor-video-delete me. So I remember to delete this later. And then you can associate key value tags with this. So I typically just put an owner tag on there with my name so that my teammates in my shared environment here know that this belongs to me. So we'll go ahead and create that empty resource group. And that's a really quick operation just because that's an empty resource. It's just kind of a logical container. And then once that's been created, we'll just hit refresh here to find that resource group. There it is. And then we can create inside of this resource group. You can see that right now there's no resources inside of here. So what we can do is go up to the search box here and we can search for storage accounts. And then we can say, create a new storage account. And then you'll put the storage account into a resource group. So I'll choose the resource group that I just created here. And then we need to provide a globally unique name that only uses word characters and numbers. So I'm going to call this Trevor SG Video 05, just to make sure that that is a unique name. And then you can also choose an Azure region where you want to deploy that storage account into. I'm just going to choose West Central US as that's located nearest to me, I believe. And then for the service here, you can optionally choose a primary service. I'm not entirely sure what this is used for, but you don't actually have to select it. But if you do have a primary service that you're going to be using it for, you can select that there. And then under performance, this is where you would specify optionally to use the premium tier that costs a lot more than the standard tier. And if you choose premium, then you can choose the premium type here. So again, if you check out the document right over here, for premium, you have the option to use premium block blobs, premium for Azure file shares. If you want an NFS or SMB file share, that's separate from the blob storage. And then you also have the premium page blobs service here as well for Azure disk storage. But again, we're just going to choose the standard performance tier here, as that is going to provide the lowest cost compared to premium by a significant margin. Now, for the redundancy, we can also choose to have geo-redundant storage here. But again, I'm going to choose LRS here, as that is lower cost. There's a bunch of advanced options that are available in Azure Storage as well. So as you can see, we can allow anonymous access to block blobs if we want to. And so what that would be useful for is if you want to provide a anonymous download service. So let's say you're hosting some, operating system ISOs, or maybe you're hosting a website where you need to provide anonymous access to certain static assets like images and video files and CSS files, JavaScript files, that kind of thing. You can provide anonymous access so that you don't have to authenticate to the storage account in order to retrieve data. But that is disabled by default because oftentimes you're going to be storing proprietary internal data that you don't want to share externally. So that's disabled by default, but you can enable that. And that simply allows your blob containers, after you create the storage account, to optionally have anonymous access. There's also an option here called Enable Storage Account Key Access, and this is enabled by default, as you can see. And what this does is when you create the storage account, you have to authenticate to Azure Blob Storage before you can read or write data to the storage account. And you can use integrated authentication with Azure Entra ID, but you can also provide what are called storage account keys, which provide full administrative permission to the entire storage account. And so that's what the storage account key access is for, is providing those administrative keys that you can use to authenticate rather than using the integrated Entra ID authentication. Also, you can require secure transfer here. So obviously you're going to want to use HTTPS access rather than HTTP just to prevent compromising of data that is in transit across the internet. You can specify a minimum TLS version. Generally, you're going to want to leave that at the latest, which is the default here. And there's some other options down here as well. So if you want to enable SFTP protocol to manage data inside of your storage account, that is optional here as well. But that does require that you enable this hierarchical namespace feature here as well. And then same thing for NFS v3 if you're going to use the Azure Files type of storage, not blob storage, but that's for NFS Azure File Storage. Now for blob storage down here, we can choose what our default access tier is. So when we upload a new file up into the Azure Blob Storage account, then it is going to choose the access tier here. And then down here, this is another setting for Azure Files to enable large file shares, but we're not going to worry about that for now. Now, another option that you have from a network connectivity perspective here is the ability to specify network access. So the default is to allow access across the internet directly using the public Azure Storage REST APIs. However, in some cases, you might have an application that's running on Azure Container Instances or Azure Virtual Machines or some other compute service like maybe Azure Functions or Azure App Service plans. And you can specify that your storage account is only accessible from a virtual network or specific IP addresses. And so that is what allows you to choose this here. But because we're just working with this across the internet for now, we're just going to leave the default, which is to enable public access directly across the internet using the Azure Storage REST APIs. And then if you do choose to have private only storage, you can specify your private endpoints down here for the storage account. All right, for data protection here, you have the option to do what's called a soft delete. And a soft delete basically allows you to delete a blob from your storage account, and then you can recover that data for up to 7 days. So as you can see right here, it marks a blob for deletion, but it does allow you to recover that data in case it was an accidental deletion. So you can do that for individual blobs, or under the storage account, as you'll see in a moment after we create the storage account, we actually have to create something that's called a blob container. So we create the storage account, but then in order to actually store blob data, we have to create what's called a blob container. And you can create multiple blob containers within your storage account, but you do have to have at least a container to store your blobs inside of. Blobs are children of containers, not children of the actual storage account itself. So it goes storage account, blob containers, and then blobs inside of the containers. And so you can enable the soft deletion. It's kind of like a trash can or recycle bin, whatever you want to think of it as, for blobs individually. Or you can actually choose to have container level soft deletion as well. So you could delete an entire blob container that has thousands of individual blobs inside of it and have the restore capability here as well. And then there's soft delete for Azure Files, but that's not related to Azure Blob Storage. That's for Azure File Storage for creating SMB and NFS file shares for your Azure Virtual Machine workloads. Now, just like Amazon S3, again, if you're coming from an AWS background, the Azure Storage Service does allow you to enable versioning for blobs. So basically, you can have a blob named index.html, for example, and then if you put another blob with the same blob name, index.html, that has some minor changes to it, rather than replacing the blob with a new blob, it's going to actually version it. So you can have v1 of the blob is your original index.html, and then when you upload a new version of index.html, it retains the original version and just creates a new version instead of replacing the blob. So that is an optional feature that is disabled by default when you create an Azure Storage account through the Azure portal here. You can also enable encryption. So if you choose customer managed key, then you can store your encryption key inside of a service called Azure Key Vault. So you'd have to create a separate key vault, and then you can store your key inside of that key vault instance. But we're just going to choose the Microsoft managed key for now. And then you also have the ability to enable support for customer managed keys for either just blobs and Azure files, or you can apply the customer managed key to blobs, files, tables, and queues, which are all 4 types of storage in the Azure Blob Storage service. And then you can also assign individual resource tags here as well. So just like I did for the Azure resource group, I'm also going to add my owner tag here for the storage account. So those are all the different options available for your Azure storage account. So we'll go ahead and just create this. And then once the storage account has been created, we can then go ahead and create a blob container inside of the storage account. And then we can start uploading data from our local system into that Azure storage account blob container. So first you have the storage account, which is what we're creating right now. Then we'll create the blob container. Again, you can have multiple. I could have one called images. I could have one called video. I could have one called website. I could have one called, assets. Whatever you want to call it is totally fine. And you can have different settings on those individual blob containers as well. Let's navigate back to our resource group here. And as you can see in our resource group, we now have a single resource of type storage account, and that is in the West Central US region, as you can see right here. So if we click on the storage account, that'll take us to the storage account console here in the Azure portal. And then under data storage here, you can see the 4 different types of storage. So we have containers, blob containers. We have Azure file shares. That's for NFS and SMB storage that you want to mount to a Azure virtual machine. We have the queue storage and then table storage. So again, we're just going to focus on blob storage here. And you can create a new container here. So let's just call this Trevor-images, for example. And then because we disabled anonymous access at the storage account level, that's actually going to deny us the ability to specify an anonymous access level at the blob container level or the individual blob level. Also down here, you can specify your encryption scope optionally if you want to, but we're not going to worry about that for now. So we'll go ahead and just create that new blob container. We could create another one called like videos. We could create another one called logs. You'll actually see there's a special one in here called $logs that's built in when you create the storage account. We could create another one called website if we want to set up static website hosting and we want to run a website inside of there. We could set that up as well. That's actually another option that you have, is to go under data management here and go to static website, and you can actually enable static website hosting within a storage account. So just like with Amazon S3, you can enable static website hosting. Same thing in Azure Blob Storage. You can enable static web hosting as well. So that's great for things like blogs or maybe web front ends that need to talk to a remote API or things like that. It's not for serving up dynamic content. For any kind of dynamic content, you're going to need things like app service or Azure container instances or Azure virtual machines or anything that can run some kind of compute service. So now that we've got these blob containers here, we can go ahead and just upload some data into the blob containers. So for example, we've got, let's go to this videos folder here. We can say upload, and then we can drag and drop files to persist them there, or we can just click on browse for files. So let me just open up a folder over here, and I'm going to go ahead and just upload this file right here. Let me drag and drop that from my Windows Explorer here. So we'll click on upload. And as you can see, we've uploaded that blob into our container. I could go to a different container and say, hey, I want to upload something here. And let's go ahead and upload this blob here. We'll say upload. And now you can see we've got some data up inside of this container. Upload another file. And this is just how you can work with it right inside of the Microsoft Azure portal. Now, something that's interesting about Azure Blob Storage is you can create something called a shared access token. And this provides short-term time-limited access to a blob container or to an individual blob within a storage container. So you can provide at the entire container level or the individual blob level. And then there's what's called a signing key here. So we would just use either key 1 or key 2. That is what that setting that we talked about when we created the storage account to enable the storage account keys. And then you can provide either read permissions, write permissions, or a variety of other individual permissions here. Like if you want to allow the SAS token to list blobs inside of a container, you can enable that as well. So there's a variety of different permissions that you can choose. And then you can choose a block of time where you want the permissions to start at. So I could put this into the future and I say maybe start an hour from now. And then you can set an expiration time as well. And then you can even specify IP addresses that you want to limit access from. So this is pretty tight security. When you share that SAS token with somebody to upload data into your storage account or to download data from your storage account, you can limit it pretty well to specific IPs, and that gives you some really good security. But if the SAS token gets into the wrong hands and you don't have a limited IP address, then as long as the time is valid, then the attacker that has compromised access to that SAS token will be able to interact with your blob container. So just keep that in mind as you are working with blob containers. You want to treat SAS tokens with time-limited access. You want to treat those like secrets or passwords. So you want to keep them sensitive, and you only want to share them with individual authorized users that should have access to that blob container or individual blob. So if we go into an individual blob here as well, we can click on Generate SAS. And so just like over here at the container level, we had shared access tokens. We can also click on the Generate SAS tab here, and we can modify the settings for the SAS token. And in this case, the SAS token only applies to the specific blob that we have selected right up here. All right. So you can also go into edit right here. And as you can see, this is an image file, so we can't really edit anything right here. We could download that file to our local file system if we wanted to. But if we had something like a text file, we could actually edit that inside of our console or portal directly here. So let's create a really quick text document. I'll just call this sample text. And then we'll open up this file right here. And we'll go ahead and specify some text like hello from StratusGrid, and we'll save that. And then we'll go ahead and upload this to our container. So I'll actually create a new container called text-files, say create. And then inside of that text files container, we'll say upload. And then let me go ahead and choose this file and say upload. Then we'll click on the blob itself, And because this is a text file, it actually has a built-in text editor right here. And so you could edit various, code source files. If you have maybe an HTML file or a CSS or JavaScript file that you really just want to do a quick edit on inline, you can do that directly inside of the Azure portal, which is a nice little convenience. Again, if you're just working with plain text files, that's a great option to have. All right, so over here under versions, we did not enable versioning on the storage account, so we don't have the ability to see versions here, but that is where you would see versions if that was enabled for the storage account. All right, so I also wanted to mention the Azure Storage Explorer utility. So this is a storage utility that is a graphical interface, and it is cross-platform as well. So even though I'm running it on Windows 11 right here, you can also run it on Mac OS, and I think it's available for Linux as well, although I would need to double check that. You can go out to their project page right here. It's not technically an open source utility, but they do have a GitHub repository to report issues with it for some reason. That's just the route that they chose to go, but there is a GitHub repository here, even though it doesn't actually have the source code for the application. And then down here, you can see the different releases. So there is a Darwin, which is Mac OS release. There is a Linux release here, and of course the Windows release. And I actually install it on Windows using the Scoop Package Manager, or if you're on Mac OS, you can install it using the Homebrew Package Manager. So if you just do a search for the Scoop Package Manager here on Windows, you can install the Azure Storage Explorer, this package name right here under the extras bucket. So I definitely recommend using the Scoop Package Manager to install various utilities like the Azure Storage Explorer and lots of other dev tools as well. All right, so Azure Storage Explorer, you can log in. It'll basically just take you over to the browser so that you can log in with your Azure Active Directory, or what's now known as Entra ID, your Entra credentials. And then once you're logged in, it presents you with a list of the subscriptions, like AWS accounts, that you have access to. And there is a filter setting. So if you go to, can't remember exactly where it is, but somewhere in these settings, there is a filter that actually specifies which of the Azure subscriptions are accessible to you. Can't remember exactly where that's at. But if you don't see one of your subscriptions showing up in here, it's quite possible that that subscription is being filtered out. So if we right-click and say Manage Subscriptions, that is where you could actually specify which of these subscriptions you would have access to right here. So if you don't work with some and you want to clean up the view, you can just uncheck those right there. And so now you can see that those have disappeared. But within an Azure subscription, it doesn't show you the resource groups here, but it does show you the storage accounts themselves. So it doesn't really matter what resource group the storage account belongs to. From the Azure Storage Explorer's perspective, it just shows you a master list of all the storage accounts that your credentials have access to in this particular subscription here. So if we right-click and refresh our list of storage accounts, we should see our Trevor SG Video 05 storage account right here. And if we go to blob containers, you can see all of the blob containers that we have already created inside of the Microsoft Azure portal. So if we go over to text files right here, we can see this text file that we just uploaded here. We can right-click and say preview and see the text inside of there. And we also have this nice tabbed interface. So we have the ability to say, hey, open this up in a new tab. And so now we have two different tabs here where we can see one container called text files and another blob container called logs. You also have the ability to copy the URL, copy the path, copy a direct link. You can also right-click and say change access tier and specify to move it to cool, cold, or archive storage. You also have the ability to edit tags on the individual blob here as well. So you could come in here and add a tag like owner, Trevor Sullivan, and then click on save. So that'll save your tags to that particular blob as well. You can also say create snapshot. So we could create a snapshot of that blob if we want to restore later. We could right click and say manage history, say manage snapshots. And now we can see that we took a snapshot of that right here. And so there's just a lot of convenient options here. So we could right click and say copy, and we could copy that into a different location. So we could say paste, and that will literally just copy from the text files blob container into the logs blob container over here. And as you can see, that finished successfully, and this blob is now existent in both of these containers. So the Azure Storage Explorer is a really nice utility. It allows you to kind of just work with all of your different resources here. You can get your primary and secondary authentication keys if you need to authenticate using something like Azure PowerShell module, for example. You can also set what your default access tier is. If you want to change the default from hot to cool, you can do that right here. You can also open this up directly in the Azure portal by just right-clicking and then choosing Open it up in Azure portal here. So again, a lot of nice integrations that allow you to work with all things related to Azure storage here. So I definitely recommend downloading the Azure Storage Explorer if you are working with the storage service. All right, the last thing I wanted to mention is some metrics around the Azure Storage Service in particular. And so what we can do with the metrics is to basically monitor our utilization of an Azure storage account. And this can be useful for doing things like cost optimization. If we need to identify storage accounts that have a very large amount of storage or a huge number of blobs inside of them, we can actually use the metrics to help us understand which storage accounts and which blobs are being used the most. So if we go to our storage account here in the Azure portal, we can scroll down and we can go down to monitoring, and then we can go to metrics. And there is actually a nice document here called Azure Blob Storage Monitoring Data Reference. And this includes a list of the available metrics. So we have capacity, which is a storage account level metric. So this will include all 4 types of storage: blob, file, queue, and table storage. But if we need some more specific metrics around the Azure Blob storage service, and we want to leave out or omit the file storage, queue storage, and table storage, there are some metrics that are specific to the Blob services under a given storage account. And so those metrics down here are things like blob capacity. So that is the total storage in bytes that is being consumed by the Blob service. Also, there is blob count. So how many blobs do we have within an entire storage account? Also, we have things like how many blob containers are there within a storage account? And then there's also an index capacity here, which is used for the hierarchical index down here. So the ones that I find most useful in particular are the blob capacity here. There's also dimensions here. So if you want to filter out and say, hey, I'm only interested in blob capacity for anything that's in the hot storage tier, I can actually get a metric dimension specifically for the hot storage tier. Or if I want to see how much storage is in the archival storage tier, I can get that as a separate dimension on the blob capacity metric as well. And then same thing for the blob count. So if I want to see how many blobs are in hot storage, there's a dimension for that. If I want to see how many blobs are in the archival storage tier, I could see that as well. And then for things like blob container count, this is a really simple metric. It's just how many blob containers were there. And then the time granularity, we only get per hour metrics. So this is kind of high level metrics. You're not going to get like per minute or, every 5-minute metrics for this. It's only per 1 hour. So just keep that in mind. You have a limit of 1 hour granularity on all of these metrics. So it's not like you're going to get instantaneous response times from these metrics. So since we just created the storage account, we may not have that much useful data as far as the metrics go. But if we go back to the metrics here in the Azure portal, we can see what is the total used capacity of the storage account. And sure enough, it looks like we probably don't have any data here yet. Once our storage account exists for at least an hour, we should see a data point at least show up there. But if we choose a different storage account, let's try a different one that I created previously. So we'll uncheck that one, and then we'll choose this one right down here and say apply. And we'll say, show me data for the last maybe 4 hours here. As you can see, we do have some data points once an hour. So 5:32 a.m., 6:32 a.m., 7:32 a.m., and so on and so forth. So you can see that my storage hasn't changed because I just have some static data in there that's not really actively changing. But if you have applications that are constantly reading and writing data to and from storage accounts, then you're going to see this fluctuate on a fairly regular basis. Also, if we want to take a look at blob related metrics under the namespace here, we can drill into blob, file, queue, and table storage. And those are the 4 different types of storage underneath of a storage account. So again, we're interested in blob storage here. So I can see what is my blob capacity. And again, that's 7.7 megabytes. So that's a little bit less than what I actually had at the account level here. So that tells me that if the account has 9.2 megabytes and I only have 7.7 megabytes in blob storage, then that probably means I have some storage in the 3 other file, queue, and table storage services. Back under the blob metrics here, I could look at the blob count and see how many blobs do I have inside of this storage account. So it looks like I have 6 blobs aggregated across all of the different blob containers inside of this storage account. And then I can also see transactions like requests. So how much data has been ingressed or egressed from blob storage over a period of time and things like that, or how many transactions have been made against this storage account over a period of time. And as you can see in this chart right here, there has actually been some activity in this storage account over the last 4 hours, which is the time range that I've selected here. So the metrics are really useful for helping to understand, how much data is stored, what are the different tiers of storage that are actively being used, how many blobs are being used, how many transactions are actually being performed against the storage account. Maybe I've got a petabyte of data sitting in a storage account, but there's no transactions happening, right? So that's a good indicator to me that that storage just is not actively being used, and it might be a good candidate to move to cool, cold, or maybe even archival storage tiers if it's not actively being used based on the transaction data from the storage account metrics. So that can help me to cost optimize my Azure storage. Something else that I did think that the metrics was going to be the last topic, but I also wanted to talk about lifecycle management here. So when you create a lifecycle management rule, by default, there are not any lifecycle management rules. But when I create a lifecycle management rule, it allows me to specify conditions where I want to delete data out of my storage account or move it to one of the colder storage tiers. So for example, I could say add a rule here. And if I want to take any blobs that have not been accessed in 10 days, right? If I say, all right, after 10 days, I'm going to assume that if a blob has not been accessed, then I just want to move it to cool storage. So I could say 10 days cool. I'll just give that a name as my rule there. And then I could specify which blobs I want it to apply to. So I could actually add an additional filter here, or I can apply it to all of the blobs across all of the blob containers within my storage account that I'm applying this lifecycle management rule to. Also, you can specify if you want it to apply to block blobs or append blobs or both. And then you can also specify if you want it to apply to snapshots and versions of blobs in addition to the actual base version of the blob as well. But we don't have versioning enabled, so we're not going to choose that here. And as you can see, if the base blob was last modified, so last written more than 10 days ago, then we could say move it to cool storage. Now, I did think that this included access times, like read operations. It doesn't seem to include that. It's only based off of when the blob was actually created or last modified here. So if it was last modified more than 10 days ago, it's not actively being updated, then we could say move it to cool storage. We could also say if it's been last modified more than maybe 180 days, like 6 months ago, then we could say, I just want you to delete that blob. Because if it hasn't been updated in more than 180 days, then maybe my application, in my specific circumstance, maybe that means that it's not actively being used by anything. So in that case, we could just delete the blob entirely. And so then we can set those lifecycle rules inside of our storage account, and that will automatically move the storage to the appropriate tier after 10 days. And then after 180 days, it will delete the blobs entirely. So that's one mechanism that you can use to help ensure that your storage account is cost optimized and that you're not paying for a lot of extra storage that you're not actively consuming in the Azure Blob Storage service. Now, there's a bunch of other topics we could get into, like blob inventory, which is like detailed inventory of all your blobs so that you can really quickly scan all of your blobs in your storage account. There's also static website hosting. There's things like object replication, your redundancy settings here as well. But we're going to just kind of leave it there. If you are doing web hosting, you can also put an Azure Front Door CDN in front of it. In fact, if you check out our channel, we actually have a video that I just did the other day on Azure Front Door as well, which is a CDN service that allows you to distribute data from Azure storage accounts like static assets like images, video, JavaScript, CSS, in HTML files, any kind of static assets like that. You can actually distribute across your CDN using Azure Front Door profiles. And then there's also the different types of storage, right? Azure File Shares, queue storage, table storage, and things of that nature. So feel free to check those out, and we may do other videos on those topics as well. But in any case, I hope this video has been useful and that you've learned some basics about the Azure Blob Storage service. Thanks again for watching. My name is Trevor Sullivan, a solutions architect with StratusGrid. Feel free to reach out to us at our website, stratusgrid.com, and we will see you in the next video. Take care.